Hey, what's up? It's Mr. Suda here. I just want to give you a few tips and some useful hints when you're working on the valence electron practice. That's on pages 21 through 23, I believe. Right. Let's start off with these pre-activity questions. All of these pre-activity questions, the answers can all be found in the notes. You can either watch the video or you can look at the PowerPoint itself. I'll attach both those things to this assignment. Right. So these again all in the notes. Next one down here, directions. Label each group or column with the correct number of valence electrons. I already labeled it on the copy that you guys received on the in the packet if you got the packet from the school. If not, we can look at our groups here. So group 1, they all have 1 valence electrons. Group 2, they all have 2 valence electrons. This out here is a group 13. Group 13 has 3 valence electrons. So on until we have group 18 out here, which has 8 valence electrons, except for group 2. This first one here, only this first one has 2. All the rest in group 18 have 8. Right? So directions says using the periodic table below, determine how many valence electrons are in each element listed below. Now this chart is useful here, but it doesn't actually have the elements on it. So instead, I'll link a really useful periodic table. So I'm going to use this one. It's ptable.com, but I'll link it. It has lots of useful information, and the periodic table is interactive, and it's super, super helpful. All right, so let's go back and look at our first question here. It says, using the periodic table above, determine how many valence electrons are in each element listed below. All right, so let's do beryllium together. So I'm going to go back to my periodic table. Here's beryllium. Beryllium is a group 2 element, so I know that it has 2 valence electrons. And that's pretty much all there is to it. So beryllium is a group 2 element, so it has 2 valence electrons. E stands for electrons. All right, so beryllium has 2 electrons. That's all you got to do in that part. All right, part 2 here. Directions using the periodic table above, determine the number of valence electrons the following elements currently have and how many they need in order to achieve a full octet. If you remember, an octet is having 8 valence electrons, right? Having that full set of 8. So sodium has blank valence electrons, which means it needs blank to reach a full octet. So let's look at sodium. Let's go back to my periodic table. So here's sodium. Sodium's a group 1 element, so I know it has 1 valence electron. So sodium has 1 valence electrons, which means it needs 7 more to reach a full octet. 1 plus 7 is 8. That's all you got to do for this part. There's a whole bunch of examples, but they go pretty fast once you get the hang of it. All right, part 3 here. Using the periodic table and your knowledge of valence electrons, determine the group of an unknown element must be found in. Use terms like alkali metals, alkali earth metals, halogens, and noble gases. Those are all like terms used to further classify elements. And if you look at this online periodic table, it actually gives you a color key for each of our classification zones. So all these ones that are orange, these are all our alkali metals. All the yellow ones here are all alkali earth metals, right? So what you want to do here first, unknown element has 1 valence electron, so it must belong to the, so if it has 1 valence electron, I know it has to be in group 1. Group 1 has that orange color. Those are our alkali metals, right? So I'm going to go back here, and I'm going to call them alkali. These are alkali metals. Right, and I know that because my alkali metals are group 1, and all group 1 elements have 1 valence electron. Right, so that's all you got to do in here, part 3. Right, last one here, we got part 4. So for part 4, it's this is the trickiest that it's going to get. So you're going to use your periodic table again, and we're going to be trying to figure out what the unknown element X, what group it has to belong to. So they're going to give you this example here. An unknown element X forms the following compound, X being the unknown element, Cl, XCl. Right, so Cl is the known element, X is the unknown. Cl is in group 17, so it has 7 valence electrons. So the whole compound has to have a total of 8 valence electrons according to our octet rule. Right, so element X has to have 1 valence electron because 7 valence electrons from the chlorine plus 1 valence electron from the unknown element has to equal 8. So the group on the periodic table that lines up, if you have 1 valence electron, you are in group 1. Right, so I'll do 2 examples here. I'll do this one Na, and I'll do this one down here where it has that X with a little tiny 2, a subscript 2 on the bottom. All right, so NaX. Right, so let's look at, I want the valence electrons of the known element. So the one we know here is sodium. So I'm going to go back to my periodic table. Here's sodium again. It's in group 1, so it has 1 valence electron. Right, so sodium has 1 valence electron. Now they want the valence of the unknown, right? So if I had 1 valence electron, according to my octet rule, I need to get to 8 valence electrons. So my unknown element has to have 7 valence electrons in order for it to balance out. Right? So if I have 7 valence electrons for that unknown element, I know that it has to be group 17. Right? Because all group 17 elements have 7 valence electrons. Right? So that's what you'll have to do for these ones here. These last two are a little bit different. If we look at this one here, let's do the first one, X with the tiny little 2 and the O. All right, so what's the valence of our known element? All right, so we'll look at oxygen. That's the one that we do know. So let me go back to my periodic table. Oxygen is in group 16. If it's in group 16, I know it has 6 valence electrons. Right, so I know that oxygen here has to have 6, it's a terrible 6 valence electrons. Right, it's got to have 6 valence electrons. Now we're going to try to figure out the unknown element. This little tiny 2 down here means there's 2 of that element in the compound. So there's 1 oxygen, but there's 2 of that unknown element. Each of those unknown elements is going to have a certain number of valence electrons. Right, so I know that oxygen has 6 valence electrons, and we need to get to 8 valence electrons, right? So 8 minus 6 is 2. So I have 2 electrons to play with here. So 2 divided by the little tiny 2 here, right? So I know that I have 2 electrons to play with, but I have 2 of that element. So 2 divided by 2 is equal to 1. So each of those x's, so x equals 1 valence electron, right? Because we have x was 1 valence electron, we have 2 of the x's, so we have 2 valence electrons in total. 2 valence electrons plus 6 valence electrons is our full octet, right? So if we look here, x is equal to 1 valence electron, so we know it belongs to group 1. I'm just going to write G1. Right, and that's all you have to do for that. If you have a little bit of tough time, that's okay. I know this is a little bit more complicated, but it's very good practice for valence electrons. Right, thanks for watching. If you have any difficulties, let me know. You don't have to do this last part here on the bottom. That's okay. But if you have any problems, let me know, and I'll see you in the next video.